Hello, my name is Tao and my group mates are MOHAMAD, FUAD and ZHENG. In this project, we are required to use ARM Cortex-based development board and at least 3 input devices and 3 output devices. So the input we use for our project, Smart Fire Detector are flame sensor, LM35 temperature sensor and push button. And the outputs are LCD, motor, buzzer and LED. In order to complete this project, we have to use some modern tools which are produced for the simulation and Cal Microvision for the coding. For further details, my groupmates will present you about it.
Hello, my name is FUAD bin HASSAN. So today I will present about the methodology for this project. So the first is functional flowchart design. The process will be start and then for the process is initialize APP2 and GPIO A, B and C, and then ADC initialization, and then system button. Then go to if the system button is pressed. For the no, the switch off all the LED, motor and buzzer. LCD display system off, and then it will go to this program where if the system is button is pressed is yes, the sensor will read the data and then the flame will read the data. So there are 3 command that can be used. For the first command, if the flame sensor value is high and temperature is higher than 40 degrees Celsius, if yes, LED red, buzzer and spotter spray motor on, and then LCD will display fire detect. If no, is flame sensor value is low and temperature is higher than 40 degrees Celsius, then LED yellow will on and LCD display high temperature. No, if flame sensor value is low and temperature lower than 40 degrees Celsius, if yes, LED blue on and LCD display normal temperature, and then it will go to A, which is the loop in the program. And then this is a design for our projects. So this is the list of the component that we use: the button, buzzer, the sensor, LED, blue, red, green, yellow, LM01 fit L, LM35 logic toggle, motor, resistor, and STM32F103C microcontroller. And this is the input for the component. For the input component, we use is flame sensor, which is connect to pin PA3, and then temperature sensor, which is connect to PA1, and then push button, which is connect to pin PC13. And this is the output. First, the LCD device, which is this is the pin that connect to STM32F103C, and then motor PA8, buzzer PA12, LED red PA11, LED yellow PA10, and LED blue PA9. So that's all from me.
My name is John, and now I'm going to present to you our project simulation. So before that, I am going to explain about the programming code software and the simulation design software that we use for this project. So for the programming code simulation, for this simulation, we use Kill Vision 5 to write our codes, where I will explain it in detail later. So for our simulation circuit design, we use 48 to design the circuit for our simulation, which is for our smart fire detector system. So now I am going to explain to you for our coding. So at first we have to include a library for the STM32, and we can also include the STD IO. Then we define this RS and EN for our LCD, and some void function for the LCD command, LCD data, and the delay function. So next, in the INT main void, we have to define the integer for our switch, where we don't have to define it again at the loop, the white loop. Then same goes to the analog value and voltage out and temperature for our ADC. So next, we set the clock for GPIO-A, GPIO-B, GPIO-C, ACD, ES, ART. Then we set the GPIO-A at low for pin 0 to pin 7 as our input port, and pin 8 to pin 15 for our GPIO-A, for the port A for our output port, as our output port, which is for LED, buzzer, and motor. So then we configure port B as our LCD port, which is to connect port D or to D7 of the LCD to port B to the embedded controller, to our controller. Then GPIO-C we set at pin 13 for our button. Then next, we initialize all the output in low state, or turn off all the output when the simulation starts. So then we change the prescaler for ADC to not exist 14 MHz. So this is the configuration for the ACD, which is for the temperature sensor that we use in this simulation. Then next, we configure the text that we want to show on LCD display in the main void. Okay, next, for our looping part, or which is for our programming part, the function of the simulation part. At first, we setting up our ADC value so that we can get the accurate temperature value for this simulation. Then we declare the input port, and we calling the input port for the switch 1 and switch 2 from GPIO-C and GPIO-A. Okay, now for when the switch, so this is the part where we set, but when the button switch 1 is not pressed, it will remain off, all the output will remain off, and the LCD will show system off, which means the system is not on. And after the button is pressed, and it will start the simulation, or turn on the system, and it will display smart fire detector, which show the simulation start. Okay, now for after the switch 1 is pressed, we are going to next section, which is for the switch 2. So for the switch 2, Stage 2 is the flame sensor. So when the flame sensor is detected and the temperature is over 40, LED red buzzer motor will turn on and LCD will display fire detected. And this this LCD command will clear the previous text on the LCD and show the state, the condition of will show the text of for this during this condition, which is fire detected, since the fire sensor detect fire and temperature is above 40. So if the fire didn't detect any fire and temperature is above 40, so the flame sensor will the LED yellow will turn on and LCD will display high temperature. So same as previously, the LCD will clear out the previous display and then will display the new text, which is high temperature detected. So the final state, if the fire sensor didn't detect any flame and the temperature is below 40, so the LED blue will turn on and normal temperature will be displayed on LCD. So this is the white function for the LCD command, LCD data, and delay MS. So next I'm going to present the simulation for our. Before we go into simulation part, we have to get the hex code so that we can run the code in Proteus. So by pressing F7 and the compilation done, then we can get the hex file on the folder that we saved. So now I'm going to present to you our simulation and how it works. So before we press run simulation, we have to insert the hex file that we get just now. So after we insert the hex file, we also have to put the hex file for the flame sensor, which is available in the project file. Okay, now we can run the simulation. So as you can see, when we didn't press the button, the system will show, the LCD will show system off, or the output, which is LED motor buzzer, will turn off. So after the button is pressed, the LCD show the smart fire detector and house is in normal mode. Its house is normal. LED blue as flame sensor is not high or no fire is detected, and the temperature is below 40 as we stated in the code. So if the temperature rises to 40 and above, it shows high temperature and the LED yellow will turn on, LED blue will turn off. So the other LED red motor and buzzer will still off since the temperature, the flame sensor didn't detect any fire. So if the flame sensor detected fire, which means the LED green will turn on to indicate there is fire. So the LED red will turn on, LED yellow and LED blue will turn off. Then LCD will display fire detected. Then the motor will turn on. Since the motor, since it's a bit slow, so we barely can see it is spinning. But it's then the buzzer also will turn on. So the LED green is put to show that the buzzer is on. So if we press the button, the switch 1 again. So everything will turn off. And the system will show, the LCD will display system off again. So that's all for the simulation part. Thank you.